record. Then we will start sharing screen. Yeah. Okay, so today we will start with new unit about generics. Generics, okay. Let me change the pen color to this. Okay, we are going to discuss generic type, okay, generics. And if you recall in the previous two new discussed data structure, that we learned in the previous couple of weeks. Do you still remember what are the two new data structures that we learned in the previous two, in the previous couple of weeks? This one, who is responsible for this one?
Stack.
Yeah, very good. Stack, is it? And the second one is responsible for this FIFO. Who is taking care of FIFO? What's the name for that data structure?
Q.
Very good, yeah. Q. Is it? We learned both, is it? And if you recall, we discussed the implementation of our own version, is it? But we also discussed that we use the Java provided one, is it? If you recall, when you use Java provided one, you need to do something like this. Is it the angle brackets? Is it like a char? Character, is it? This angle brackets, is it? At that time, I said that later on we will learn, is it? And with the stack and the queue, is it? Provided from the collections framework, is it? And you can use it for various type, is it? But over here, of course, there should be some reference type. So it's not limited like our own version. Is it? Our own version, we can only use it for either integer or character or string at that time when we learned, is it? And over here, you can also do like, if you record stack, a string, is it? And we can also do like a stack integer, is it? But it's all reference type. You are not allowed to do this. That's not allowed, is it? So not allow primitive type. Primitive type. Okay, so keep this in mind, is it? So it's very flexible, is it? So basically we already saw this, we already used this, is this? So what is this? Basically, this is what we will learn today. It's about generic class and generic methods, okay? So that's what we will learn, okay? The concept. Okay, so that, and anywhere else, if you recall previously, who remember where else we also see this kind of angle brackets used? Who remembers?
An array list.
Yeah, very good. Array list, yeah. Array list is it we use. And if you think really hard, you may also record even for the comparable interface. Is it? Interface. And last week or the week, anyway, last couple of weeks, we also learned the iterable interface. And the iterator interface. Is it? And if you read the official document from Java, you will also find basically these two interfaces also support generic. Okay. So we already saw some of this, is it? But we haven't learned that concept, is it? Okay, so now let's take a look at this class. So this is also in our class website. I have this example. Okay, it's called Java Generic Example 1. Okay, there are 3 Java files here. Okay, so we will take a look at the very first one called generic type. Is it? If you take a close look, it's just a class, is it? But this part is new to us. It has angle brackets. Within angle brackets, you plug in something, is it? So generally speaking, in Java, we like to write with capital E, or capital T, capital E, or capital V, something like that. Okay, so this generally speaking represent type. This represent element. And this represents value. You can choose whatever. Okay, if you say, oh, I want A, I want B, that's also fine. You can also use a small one. Okay, that's also allowed. Okay, you can also use element. Okay, whatever, that's also fine. Okay, it's just in the professional world, the practice is to use the capitalized single letter. Okay, and also like a big K, etc. Later on, we will learn like that's regarded with the key value pair. Okay, so anyway, here is T, etc. So what does this represent? Then this defines that this class is a generic class. Okay, with this angle brackets and this T. T is not specified as what type. It just represents a generic type, kind of like a template. And later on, you can plug it in with like integer, string, etc., Boolean, character, etc., employee, whatever you want to plug in, some reference type, is it? So this is, so basically, if you define your class like this, then that represents your class, this generic type class is a generic class. And generally speaking, we call this angle brackets, and T, we call it type parameter. Yeah, type of parameter. Okay, and then later on, if we take a look, this class itself is very simple. This is instance variable. Is it? And the type is what? Is T. It's not a defined type as previously we learned. Is it? In our instance where you need to give a specific type. Is it? But here we didn't give a specific type. It's just a T. Is it? And then we have 2 methods, is it get and set, is it? And okay, this is our first quiz question. What are those 2 methods called? Is it a class method, instance method, and some other type of method? What are those 2 methods, get and set, belong to here?
Instance method.
Yeah, it's instance method, okay? Remember that, okay? These two are two instance methods. So this class doesn't have class method, okay? You can send your answer to the chat, okay? And let's take a look. Then for this get method, so this is accessor, is it? It's very simple. What it return? It just return T, is it? And it uses this dot T, is it? And then for set method, the parameter type is what? Is T. It's consistent with the class generic type. Is it? What it does, it just do the assignment. Is it? Okay, that's what it does here. Okay, this class itself, not a lot of new things. Is it? It's just this angle brackets. So type parameter is new, and the instance variable can be generic type. Return type can also be generic type. Parameter can also be generic type. But this doesn't mean whenever you write a generic class, all instance variable need to be generic type. Okay, it's okay if you said, oh, I want to do something like this. That's perfectly fine. Okay, then in this case, you can have another function, the public integer, like a get number. You just return that number. Is it? That's perfectly fine. So you can also plug in whatever other function, don't use generic type. Okay, that's perfectly fine. Okay, so this is this class we define. And then let's take a look at the driver part that we use this, okay. Okay, then let's see. The very first, so this is a variable, is it? And this variable, what's the type? Did you see? We try to use our generic type that we just defined, is it? And you plug in with a string, is it? And also be careful, okay, in main, you need to plug in with a concrete specific type, okay? Specific reference type. Okay, like here, string. Is it? You cannot do T here. That's not allowed. Okay, so be careful about this. You must plug in with a specific type. In this case, string. And must be a reference type. So you cannot do int. So not allowed this type, okay? And then in this case, I needed to create, because it's a class, is it? So I needed to create an instance. So you can call new this constructor, is it? But you can see here. And over here, I just leave it empty, is it? So it knows that it will take the string type. It knows. Of course, you can also do new generic type, plug in with string. That's also fine. Okay, but generally speaking, we don't do that because you will see some warnings that it's redundant declaration. So it's not needed anymore because it knows, the compiler knows that I will take the string type for this generic, okay, when I create this object. Okay, then what next? So over here, this we call it a type argument. Okay, argument, okay, when you call it kind of. And then you can call it set method, is it? And plug in with some string, is it? And also here, be very careful is, let me uncomment out this. If I uncomment out, I call set, because you may say, oh, it's generic, is it? Oh, I can do string, I can also do integer, is it? But did you see it's a squiggly inside? It said incompatible type, is it? Because what? Because G1 associated with string type. Okay, with string, not integer. Okay, so we need to. So over here, you see, is it gave compilation error. Is it compilation error? Is it later on we will see? You may ask, why do we need a generic type? Is it yeah? Okay, so this won't work. Is it? And then next, let's see. Next, we have G2 variable, is it? And basically, the type is what? Is also a string, is it? And you also call generic type, is it? And you set Java hello world, okay? So we have these two objects already created. And then in this same program, is it? Then for I1, what you plug in? You plug in with integer, is it? And I2, same thing, you plug in with an integer, is it? So that's why now you see the flexibility, is it? So you just define a single class, is it? Define a single generic class, is it? But when you use it, when we use it, is it? We can plug in with various types of type argument. Various types of the argument, is it? You can plug in with string, you can also plug in with integer, you can plug in with employee, with account, with geometric object, whatever, is it? So it's very flexible. You don't need to, for each type of the class, you define a new type. Is it like generic type, integer, generic type, string, is it? So it saves a lot of work, is it? So that's the benefit of generic type, okay? And then next, let's see, over here, yeah. So within this main related with class, is it? We also have this method. So this method, this part, nothing new, is it? Because it has static. That means, and the name is called is equal. The return type is Boolean, is it? So this class, or this method is what? It's a class method. Is it? Because it's static. Return type is Boolean, name is called equal, is it? And its parameter. There are two parameters, G1 and G2, is it? And both are what? Both are that generic type, is it? Some generic class type, is it? So it's some generic class, is it? And if you take a close look, you will find before the return type, we have that angle brackets and type, is it? So we have that type parameter. So then this means this method, so this method is a generic method. So this concept is kind of like you see in Word or PowerPoint, is it? And you say, oh, I want to write a letter. You can pick a template, is it? And then you can plug in your customized contents, is it? So a little bit of like that kind of concept, is it? So this method is a generic method, is it? So that means the parameter is some generic type class, is it? It doesn't need to be generic, need to be integer or string type of generic type, is it? It can be some generic one, okay? So if you wanted to define a method as generic method, remember to also add this angle brackets, so the type parameter before return type. Okay, remember before the function return type. And with it, it's pretty simpler, is it? You just call it member method, is it? And why over here it can call that equals? Because if you recall, if you go back, oh.
Because it's generic, right?
Yeah, okay, where is my, hold on. Let me get back to that file. It's just, if you take a look at my generic type, I don't have the equal method, is it? And what get return is a generic T, is it? But over here it calls the get, the equals, is it? Basically equals is from what? It's from the object class, is it? Objects. And here T is a generic one. Okay, so that's before, that's because in Java legacy code, we don't have the generic stuff. Okay, it's imported later, and it's I think it's learned from C++, the template concept. Okay, but anyway, this equals method, it belongs to who? Object class. The object class is the root class, is it, in Java, and it has like the toString, is it, some set of its own methods, is it? So here, this over here, you call this equals is it's from the objects. Okay. Okay, so this is regarding this method is equals. Then let's take a look. How do we plug in? Is it? Okay, then over here, we want to call that is equals. Is it? There are multiple ways you can call. Okay, so over here, we specify our class name and then dot. Is it? And over here, because you plug in G1, G2, is it? G1, G2 are string generic type. Is it? That generic type. So that's why over here, you also plug in with string. Is it? So this is our type argument. Is it? And then let's see over here, you can also call is equal without the dot. Is it? You just directly call the method. That's also fine because it's defined within the same class. So you don't need to mention the method or the class name. That's also, but this time, did you see you plug in with two integer generic type? Is it? Okay, so that's regarding this is equal. Then let's take a look at the third class in this example. This third class, if you take a look, it's pretty simple. I just define class called utility, is it? And it has a method called compare. Return type is Boolean. It's a static method. Is it? A class method, and it has two generic type plug in G1, G2, and So this is a type argument, is it? And then it's basically the same as that is equal method, but it's in a different class here, okay? And then if it is this case, then did you see that compare method belong to the utility class, is it? So each time if you want to call the compare method, then you need to always do utility dot. Not like over here, is it? This is because it's within its same class, is it? So in this case, you need to call, or you need to specify the class, is it? This is class method, so which class it comes from, is it? And there are two ways, two approaches. You can plug in with a type argument, or you can just directly call the method. That's also fine. You can also you don't need to plug in, and it will base on its judgment based on whatever the parameter parts is. Okay, so that's also fine. So here, this example just shows us multiple ways, okay, when you call a generic method. Okay, so this is the first example. Then let's take a look at our second example. Okay, second example is regarding array list, as previously we learned array list. And the array list, so let's see. So for this V1, it's an array list, but it is an integer array list, is it? And this is, you can script this out with empty brackets. That's generally recommended. If you take a look over here, here I have the warning. This is redundant, is it? And I have the warning. So it's not recommended this way, okay? But it won't, it's not an error, okay? For this is a character, V2 is a character of array list, is it? And then for V1, you can add in integer, is it? And I then call a search function. Later on, let's take a look at the search function, okay? And then, next, let's see. I fill in and I call the search function. And in this second loop, so over here, is it over here? I use the loop through 97 to 123, is it? And over here, because for V2 is a character, is it? It's the wrapper class, is it? It's a wrapper class. Wrapper class, and it's a character, is it? So that's why over here I have this character class C and a new character, is it? And over here, what I did is, this is an integer, is it? And then I put a parenthesis and char, primitive char. So who remembers what is this called? What does this call?
Casting.
Yeah, this is called casting, is it? Yeah. So you convert integer to character, is it? To character. Okay. So okay, this is our second quiz question. Second quiz question. So character. So char J does what? Does casting. Okay, this is your second quiz question, just a review. So you can send your answer to the chat. Okay, and that's this part, and then we call the search method. Okay, so next let's take a look at a search method. Okay, so this search method, it's a generic method, is it? And it take in a generic array list, is it? And the item you want to search is also a generic type, is it? And what you compare, you just want to find the item, is it? If it is equals to this item in your list, is it? And if it is, you return its index. That's what this search method does, is it? It's also pretty straightforward, this case, is it? And then you can see when you call this search, you can plug in with integer, you can also plug in with character, is it? So this provides us more flexibility, is it? You just write a single search method, and then you can plug in whatever type of array list, is it? We don't need to write hundreds of search methods for each different type. You just write a single one. So that's the benefit of generic method here. Okay, so far we already kind of get the basic idea about generic method and the generic class. Okay, generic class. Okay, then next, let's see this one maybe. Let me quick check if this makes sense. Yeah. Okay, yeah, how about let's go over this one first. And this is a very simple, not a lot of code, okay, for this class, if you take a look. So I just have a driver class, is it? Within it, I have a main method, okay? And over here, I define, so in the same Java file, I define another class called, this class is called max, okay? And what this max is, it has a maximum method. This maximum method is a class method, is it? The return type, be careful. Return type, return what? It's a return the comparable interface. Is it? Previously we learned, is it? So it's return a comparable interface. And the two parameters are also comparable interface, is it? And then within it call, okay, comparable interface has a compare to method, is it? Just use compare to method to decide which one is greater. C1 is larger or C2 is larger, is it? That's what it does here. Okay, and then next, let's see. In main, what did we do? In main over here, I try to compare a string and an integer. That doesn't make sense, is it? Kind of, is it, if you think about it? But did you see over here? Oh. If you take a look at the code over here, is it? There is no error reporting, is it? Everything looks fine, is it? So no error so far, is it reported? Is it? So far, no error reported. Oh, you may think I did a good job, is it? I write a good program, nothing is wrong, is it? Okay, then let's try to run it. And can you see the output? Right now, you see all of those red arrow message? Can all of you see the, because I'm not sure if it's share screen, sometimes.
Yes, we do see that.
Oh, okay, very good. And did you see, even though the program looks fine, but when you run, it brings off this error message, is it? And say, oh, some exception, is it? And what it complains is, it says some class casting exception, is it? And over here is a kind of integer cannot be, I bet it's converted to a string something, is it? So it has error, is it? Yeah, so then let's go back to the code. So that kind of error is when you program wrong, is it? It has error. So that kind of error called runtime error. Is it? Runtime error. Okay, and this comparable over here, basically, we call it raw time. Is it? Yeah, this is kind of from the legacy code, okay, from JDK 5.0, okay, and the legacy code. You are still allowed to use, is it? But you can see this will call runtime error. Is it? You don't want this kind of thing happen, is it? You write a program, you think it's perfect, you production it, and then, because sometimes when you do testing, you may not test in some special case, is it? Okay, let's do this. Then I will comment out this, and I will uncomment the second line of code. Okay, and if you take a look over here, this class, this time, this method, is it? What this method does is something here. It has angle brackets. Be careful, okay, here it has 2 angle brackets, okay? But don't worry, I will explain this, is it? And the method parameter is some generic type. Is it? Generic type. So basically this max method is what? It's a generic method. Generic method. And the type parameter is T. But this time the type parameter has some limitation. Okay. Or we call it, I shouldn't say limit, some restriction. Has some restriction, okay, called extends comparable. And you can also see for this comparable, it's also consistent with the specified generic type T. Is it? And this part, don't worry, okay? Don't worry. Because generally speaking, you previously, you remember, whenever you mention an interface, it should be implements. Is it? Not extends. You cannot do something like this. Is it? Normally we say you implements. Is it? But here we said extends. What that means later on we will see. But this time, after I change this, did you see? You have the squiggly line here. Is it? And if we take a look, it says the type is not, cannot be applied to the given type. Is it? So it reports some error. Is it? But this error report right now, is it? So your program cannot be wrong. And this kind of error is compiling error. Okay, so your program cannot be compiled. And we want to catch as many compiling error as possible. Is it? As many as possible, okay, at this stage, so that you can fix it. Is it? To avoid your program also will get some runtime error. Is it? So this example purely just show us, okay, the raw type, you see, can cause runtime error a lot of cases, okay. But with generic type, generic class or generic method, then we can avoid that kind of error. So this is another benefit. Okay, another reason that's why we also needed to use generic. Okay, so also keep this in mind. Raw type is not safe. Okay, raw type is not, it's unsafe. Okay, keep this in mind. Okay, that's this example. And then next, let's take a look the other example. Okay, Java generic example 2. Okay. So we have 2 Java files. One is we define a class called measurement generic. And if you take a look, the generic, this time, it all, not just you, so the type parameter allow multiple type parameters allowed. Okay, it's not just a single one. So this time, see, one is T, and then comma, second is U, is it? But this U has some limitation. It says extends number. So what does this mean? This means this, we call it bounded type parameter. So bounded type, okay. So it's a bounded type. So that means what? In this case, you can be number, class, or its subclasses. So any of its subclasses. Is it? So integer, float, double, something like that. So you cannot be string or employee. Okay, that's why we call it bounded type. Okay, so it's being restricted to certain type. And that type is number or any of its subclass. Okay, so that's what this generic means here. Okay, then for this class, it's pretty straightforward. We have two instance variable, type and measurement. Is it? We have the respective get method and the set method. Is it? And we also do the toString. Is it? And then let's take a look. The driver part, okay. Then for the driver part, over here, is it the first object variable y is what? It's a string and integer, is it? And then I call the corresponding, let's take a look, is it? I plug in, so I call the corresponding constructor, is it? Okay, so that's this one. And then you can set the measurement and set the type, is it? And the second one, second object, it's Boolean and integer. Is it Boolean and integer? So then you can set measurement as integer and set Boolean with true, is it? And then you can print out that, is it? Okay, and then next one, let's see, the third one. The third one, the third object is a string and a float. Is it string and a float? So then you need to, when you call set, you need to plug in with the corresponding one. Okay, corresponding one. So not a lot of new things here, is it? But what here we see, this is regarding that U part. Is it? You plug in with what? Integer and the float. Is it? Because both integer and the float are subclasses. Subclasses of number. Is it? So that's why both are allowed. Okay. Okay, so this is also easy to understand, is it? And the next, let's see, over here, I create an integer string. Is it? So this is nothing, an integer array, is it, with those specified numbers, is it? And then I call some method called is ascending, is it? And next, I create a string array, is it? And I call the same method is ascending. And for this is ascending method, is it? Oh, for this is ascending method over here, I plug in with integer array, is it? It's integer array. Is it? And here I plug in a string array. Is it? So looks like this is ascending based on whatever you call. You can judge it's a generic method. Is it? Okay, then next let's take a look what this method looks like. Is it? This method what it looks like is, okay, it's called is ascending. And the parameter type is an array, and it's a generic type. It's a generic type. And what it returns is it's a class method, and it's a generic. Is it T? But this generic must do what? Over here, it says it extends comparable. Okay, it extends, but comparable is an interface, is it? So this kind of bounded type, it's also bounded type, is it? That just means this bounded type, so the class must implement comparable interface. Okay, assuming you have an employee class that didn't implement this comparable interface, then if you want to call this is ascending, that will cause trouble. It won't work. So if you want an employee array also be able to plug in, your employee class must also implement the comparable interface. Okay, that's why previously you see we learned is that when we define some class, we make that class implement the comparable interface. Okay, that's because later when we learn collection framework, we will also see this case a lot. Okay, so anyway, so over here so this is a bounded type. This bounded type, what? It extends comparable. Okay, that means the corresponding class must implement the comparable interface. Okay, then what it does is pretty straightforward. It's use a loop. Within the loop, you compare the two consecutive element. Is it you because this T implements comparable interface. Is it? That's why over here you can call compare to method. Is it? You can call compare to method is that comparable interface method. Is it? That's why you can do this. Is it? Okay. So that's a general idea over here about here. And when we plug in over here as an integer and string, is it? So both of these two class, if you take a look at their official Java document, you will find both of these two class implements comparable interface. Is it? That's why over here you plug in with integer array, it works, with string array, it also works. Okay. Okay, so that's the introduction part of generics. So we are done here today, and tomorrow we will learn